computers. You use them every day. You're never more than 20 feet from one. But did you ever sit down to wonder, how do they work exactly? Well, I'm here to tell you. The basic computer consists of three things: the processor, the memory, and the input-output devices. These three modules make up the architecture of your computer and help it operate. To understand this architecture and how the computer works, you first need to understand how a computer stores and reads data. Your computer uses a system of storing data called binary. Binary is in base 2, which means the only numbers are 0 and then 1. If I have the number 1010 in binary, I would read it from right to left. The 1's place here has a 0 in it, so I don't add 1. The 2's place has a 1 in it, so I add 2 to the total. The next place has a 0, so I don't add 4. The next place has a 1, so I add 8. The total is 10, the 1, 2, and the 1, 8 added together. The basic unit of a binary is a bit, or a value of either 1 or 0, on or off. Think of it as a light bulb. If you link 8 of these together, it is 8 bits, or 1 byte. But basically, a computer recognizes if the bits in these 8 bits in a row are either on or off. They represent numbers from 1 in the first slot located on the right, to 2 in the next slot, to 4 in the next, and 8, then 16, then 32, then 64. Keep on going, doubling the numbers each time. So say if the third light and the fifth light from the right is on, it will represent 20 in binary. The highest number 8 bits can represent is 255. Basically, your computer uses these values to communicate with each other. It uses addresses, which are fancy terms for location and memory, represented by these binary numbers to access data stored in that location, i.e. letters, numbers, and more. Imagine if you have a home address and you want to see who lives there. The home is the address, and the people inside it are the data. Here's an example. If I want to see the data stored in address 12, which is 1100 in binary, the leftmost again being 1 and then going to the right 248, I input 111 into the input switches and I get my output, which for example could be 11010100, which is 293 in binary. This output could then be used somewhere else to access another byte of memory or to output to something else, i.e. RAM or your monitor. How these modules in the computer use binary to communicate with each other is not very complicated, but it's also quite complicated at the same time. When you first turn on your computer, something called BIOS, or Basic Input-Output System, starts up. The BIOS basically gets everything up and running in a computer, sort of like a car key starting a car. The BIOS first checks the settings set for how you want your computer to run, the black and white screen at the beginning of the startup. Then checks to make sure everything in your computer is working correctly, and then finally checks if the operating system, or OS, is on your hard drive. It then hands off control of the computer to the OS. The OS basically connects the hardware of your computer to the software. This is when your computer starts getting to work. First, the CPU gets an instruction code that is loaded into RAM by a program such as Microsoft Word. RAM means random access memory, meaning memory can be stored there and accessed randomly. The program you're running loads data into the RAM, and then the CPU then takes that data and executes the instruction in order of storage, going from memory slot 1, then 2, then 3, etc. down the sequence in RAM. The computer then takes that instruction, executes it, then grabs the next address and sequence in RAM. It continues this process down the sequence of addresses until there is nothing else to execute, which never really happens unless you turn the computer off. By now, you're probably wondering how the CPU, this magical square inside of your computer, can do all of this and know how to do it. Well, let's dive in and find out. First of all, a basic CPU is made up of 4 things: a control unit, an arithmetic logic unit, aka the ALU, the bus, and the registers. Let's start with the most simple and easy one to explain. The bus is basically like a car on a single lane road. You have a car carrying people, data, and computers, to a destination, but only that one car can be on the road at the time. Basically, a bus carries data around your CPU, and only one set of data at a time. The registers are also really easy to understand. They just store data. They also have a set and enable wire to tell them when to store and when to output that data that they have stored. Most modern CPUs have upwards of 64, but that's it for registers. The ALU is a module in the CPU that does every bit of math that your computer does, taking 2 inputs and then getting an output. Now, not only does it do math, it can carry out other specific functions like compare, modulus, and logic like not, and, or, and, XOR. The final module is the control unit. This module takes the instructions from the RAM and tells everything else in the CPU what to do with it. Like a commander in the army, taking orders from the general and telling the troops how to execute those orders. These are all set up in the CPU like this. Now this begs the question, how do these all work together? Well, first of all, when the CPU gets its first instruction from RAM, it goes into the control unit through an instruction register. This instruction is then decoded inside the control unit by a very complicated process, and then the control unit tells the rest of the computer what to do. Say we wanted to add two numbers together. First, we would get an instruction from RAM to save to our first number sent from RAM in one of the ALU's registers. Then our CPU would request the next number from RAM via the bus and get the next number and store it. It would then get an instruction from RAM to add them together and output an answer. If we wanted to store this answer, it would be stored in one of the CPU's registers, or we would output it to the hard drive, RAM, or monitor. Most modern CPUs can do each of these instructions at less than 1 nanosecond. That's less than a billionth of a second per instruction. So your computer is processing data at over 1 billion times a second. Imagine how long that would take to do by hand. Makes you appreciate what you're using. And this is not including inputs of keyboards and mice and other modules in the CPU like buffers and cache. This process like pipelining and so much more. This is only the most basic representation of a CPU. So that's how the wonderful device you're using right now works. Granted, the one in front of you does this much faster and has a lot more parts, like the graphics card, multiple cores in the CPU, GPUs, multi-threading, server and internet connectivity, and much, much more. But for now, that's just the basics.